Today we are going to discuss about implementation of a stack using linked list. First of all, we should know what is a stack and what is a linked list. A stack is an ordered collection of data items into which new items may be inserted from one end and items may be deleted from the same end, which is called top of the stack. The last item inserted into the stack is the first element to be deleted. For this reason, a stack is sometimes called as LIFO list, last in first out list. We can implement a stack using array and using linked list also. We have seen already how to implement a stack using an array. Now we will discuss about how to implement a stack using linked list. Adding a node to the front of a linked list is called push operation. Deleting a node from the front of a linked list is called pop operation. Thus, a stack may be represented as a linear linked list. The first node of the list is called top of the stack. See, there is a linked list which is having 4 nodes: node 1, node 2, node 3, node 4. Every node contains two values or two parts. One is data part, the other is link part. This is data part. The second part is link part, that is address of another node. So every node contains two members. One is data of that particular node and it is linking to other node. Again, the other node also contains data and it links to another node. So every node, so linked list is collection of so many nodes and every node is collection of two fields, data and address of next node. So a node is a struct node which is having two members, data, say data of a particular node. Then the second part is address of another node. Say if this is a node which is having two values or two parts, two members, node, data part and next part. This is a node where every node contains two members. One is data, the other is next. What is next? Address of next node. Next is nothing but address of next node. Address of next node. So struct node. Node is a structure which is having two members, data and next. What is next? It is of type struct node. It is of type struct node. It is a pointer, means address. It holds address of another node. A variable which holds address of another variable is a pointer. So next is a pointer which holds address of a struct node, another node. So the struct node is redefined as node type using type definition function. Suppose if you declare a variable called S is a variable of type node type. Initially assume that S is null. S is null. So initially there are no nodes in the array or no nodes in the list. Then one by one nodes you can add. See how we can add nodes. Initially assume that node type S is a type, S is a variable of type node type. Node type means which is having data and address next. What is next? Address of next node. Initially S is null. We assume that there are no nodes. Stack. Initially we assume that empty stack. S is null means empty stack. Stack is nothing but a list. We are trying to implement a linked list. That implementation of just like implementation of a stack. See initially S is null. There are no nodes. Empty stack. Add one node. One node is created. So the stack and the linked list is null. This is the first node. So this node becomes linked list or this node becomes a stack. So S is pointing to 10. Assume that S is top of the stack. S means stack. It is top of the stack. Then add one more node. So adding a node to the linked list at the front end is said to be push operation. So push S comma 10. So S is null. push s comma 10 means a node is created with information 10 as the linked list is null or stack is null. This is the first node of the linked list or first node of the stack. So it forms a linked list with one node. Then try to add another node, push s comma 20. So create another node 20, add it to previous linked list at the front end and make it top of the stack. So this is the first node now. So this is top node, 20 is top node and next node is 10. So a stack is created with two nodes. Again push one more node, push s comma 30. So new node 30 is created and it is added at front end and it is becoming top node. So now 30 is top node. The most recently placed element is 30, that is top node. Then push one more element, push 40. Now a new node is created with information 40 and it is added at front end and it is becoming top node. So top is 40. So see, every time you push the new variable or new value that is pushed onto the stack is the top node. So here initially stack is null. The first node is created 10, 10 is your top. Then 20 is created and it is added at front and it became first node. And 30 is added and it became first node. And 40 is added and it became first node. So now top is pointing to the most recently placed element 40. Top is pointing to the most recently placed element 40. Suppose now if wanted to delete elements, deletion of element from the stack is said to be pop. So deletion of element will be performed from again front end or top. Let us assume that there is a stack. There is a stack having 4 nodes. S is pointing to first node, that is name of the stack. Say it is top of the stack. S is pointing to name of the stack or name of the linked list is S. So which is we can consider as a top of the stack. So S is pointing to first node 40, then next node is 30, next node is 20, next node is 10, next node is there are no nodes, null. So every node contains address of next node. Last node contains address null. So address null indicating that it is the last node of the linked list. Then you wanted to pop an element. There are 4 nodes in the stack. We are applying pop. So it has to delete top node. It has to delete top node. That next of top node becomes top. So here see 40 is going to be deleted and 30 becomes your top node. Top. Again you wanted to pop one more node. The most recently placed element out of these 3 elements is 30. 30 will be removed and 20 becomes your top. So this is top. Again you wanted to delete one more node, 20 will be removed and 10 becomes your top. And you wanted to remove one more element, the 10, the only node also will be removed and S is null. So initially stack contains 4 nodes, then you apply pop, stack contains 3 nodes, then you apply pop, stack contains 2 nodes, then you apply pop, stack contains only 1 node, then apply pop, stack contains null nodes. So like this, whenever you wanted to add a node, that is called push a node. So you add a node at the front end of the linked list and you make this as a name of the linked list. Assign the name of the linked list to the first node, that is which is nothing but top of the linked list or the top of the stack. The same fashion, you wanted to delete a node, the first node will be deleted or top of the node will be deleted, so that it reduces linked list by one node. So which is said to be pop operation. Adding a node at front is said to be push operation. Deleting a node from front end of the stack is or linked list is said to be pop operation. Let me explain the push function. So push is adding a node to a stack at front end. So here there is a function called push. P is your stack, X is the value of new node to be added. Now assume that node type S. S is a stack. Initially assume that S is null. There are no nodes in the stack. We started with null stack. call push function push s comma 10. If I wanted to push a node with information 10, whenever I call push function s comma 10, s is null, s is my stack, 10 is the value of the new node to be added. So see, the statements of push will be executed. These two parameters will be passed and will be placed in p and x. So what is p? P is your stack, right? P is your stack. And what is x? X is 10, value of new node. So inside Q is node type memory allocation of size of node type. That is, it allocates memory. It allocates memory for Q. A new node is created. Then Q data is X. Here it contains two parts, data part and next part. Q data is X, X is 10. Q next is null. Next is null. So I have created a new node. Stack is empty. I have created a new node. Then I am checking. If P is equal to null, what is P? Your stack, whatever you have passed, this is P. Or yes, P is null or S is null. If P is null, yes, stack is null. If stack is null, stack will be Q or P will be Q. So this will be stack or this will be P. You may call stack or P. Stack outside the function, inside the function it is P. Okay. So a stack is created with only one node. So that is the top node. Suppose if I wanted to add one more node. Now I have one node with information 10. It is yes outside the function. So next is null. I have a stack with only one node and I am going to add one more node. I am applying push function s comma 20. Means I have to create a new node and I have to link it to the previous stack at the front end. I have to push a node. So push node with information 20. Again execute this. So s is, there is only one node in the stack. S is copied into P. S is copied into P, then X will be 20. Again, it creates a new node Q. Q. Q is new node. Q data and Q next. Q data is 20. Q next is null. I have a stack and I have a new node. Then see here. If P is equal to null, what is P? Inside the stack, inside the function, S is your Q. S is your P. S is P because I'm passing S to the function. I'm passing S to the function. So S is nothing but your P. If P is equal to null, no, P is not null. P is having one node. Now I wanted to push 20 and 20 should be the front node and 20 should be the front node. So if P is null, no, P is not null. So else part will be executed. Q next is P. Q next is already assigned to null. Now I am making it as pointing to P. Q next is pointing to P. Then P is Q. P is pointing to 10. Now I am making it point to 20. Now this is P, which is nothing but stack. Outside the function it is stack. Inside the function it is P. Inside the function I am calling P as my stack. Right? So this is stack. So stack pointer or stack top is pointing to 20. Then 20 is pointing to 10. Now the linked list will be like this. There are two links. There are two links. First link is 20, which is nothing but your stack. Second link is 10. The next link is null. Let me explain with one more. Already we have added two nodes. So stack contains two nodes. Stack is already having two nodes. Top node is 20. The next node is 10. Most recently placed node is 20. S is a stack which is having two nodes. Now I am trying to push one more node. Push S comma 30. Indicating that there is a stack. I am trying to push one more node. I am trying to add one more node at the front end before 20. So as usual, push s comma 30 means s is your p inside the function and 30 is your x. So s or p. So this is s, or you may say p also. So create a new node, assign value 30 to its data, and next is null. So create new node, create q data is 30, q next is null. Then next statement. If P is null, what is P? Your stack. Is it null? No, it is not null. So else part will be executed. So else part. Q next is P. This is Q. Q next is pointing to null. Now I am pointing to P. This is P. So I'm making 30 as first node, and next node is 20, next node is 10, next node is null. Then, and I have to make this as my top node or first node. So P is Q. So this is P. Outside the function, it is S. So now stack contains 3 nodes. 30 is my first node, then next node is 20, next node is 10. This is top node, that is S or P. Suppose if I wanted to add one more node, if I wanted to add one more node, push s comma 40. I wanted to add a node with information 40. Already stack is having 3 nodes. Create a new node q. Q data is 40. Q next is null. Then see here, if p is null, no, stack is not null, stack contains already 3 nodes, then else part will be executed. Q next is p. Q next is already pointing to null. Instead of pointing to null, it pointing to first node of stack. Then p is q, so name of the stack should be pointing to new node. This is stack, or this is p. So the stack now contains 4 nodes. First node is 40, like this: 40, 30, 20, 10, and this is your stack, or inside the function it is p. Now stack contains 4 nodes. What is the first node? 40. If you attempt to delete, 40 will be removed. So push operation is nothing but every time you call a push operation, it creates a new node. If already the input stack is null, then this node will become the first node. If stack contains one node, the new node becomes first node, and already existing node becomes second node. If already stack contains 2 nodes, the new node becomes first node, the previous 2 nodes becomes the next nodes. So always the new node is the top node or first node of the linked list. So now I'm going to explain you about the function pop. Pop means deleting a node from top of the stack. For example, here stack is a linked list. For example, assume that stack contains some 4 nodes. Already we have added 4 nodes. First node is 10, second node is 20, 30, then 40. This is your top node or stack. Now stack is having 4 nodes. The first node is 40. So the topmost node is 40, most recently added value. Then next node is 30, next node is 20, next node is 10. Now if we attempt to pop some value, uh, x is pop stack. X is pop stack. So pop one element from the stack, pop one node from the stack, and whatever the node that is deleted, the value of the node is placed in X. Now I'm calling pop function. I'm inputting S. S is a stack consisting of 4 nodes. The topmost node will be deleted. So you wanted to delete this pop node. What is the statement that is going to be executed? Let me explain. Pop P. So pop P. So what is P? In the main function, S is my stack. S is passed into the function as P. Now P is my stack. In the P, where this stack, I'm going to delete a node type Q. I'm using a variable called Q, which is of type node type. Then I'm assigning Q to P. So this is Q, Q to P, S or P. S is nothing but stack. Inside the function, it is P. Q is P. New variable is pointing to the first node. I wanted to delete this node. If I wanted to delete this node and the next node becomes my first node of the linked list or first node of the stack or top node of the stack. Suppose if Q is null, what is Q? Q is pointing to first node. If Q is null means there is no stack. If there is no stack, error, empty stack, error message will be displayed. If Q is not null, yes, it is not null. So this has to be deleted. So if you delete this node and next node, this 30 to 10 becomes your new linked list. So P is Q next. This should be P and X is Q data. Q is already 40 pointing to 40. X will be your 40 and free Q 40 will be removed and return X. X will be returned. Now it removes one node and now stack becomes only a stack consisting of 3 nodes or linked list consisting of 3 nodes 30, 20, 10 and this is your P or this is your S. Now again try to remove one more node. X is equal to pop S. Pop S means function to delete one node from the existing stack or existing linked list. Suppose say this is a linked list stack. If you delete first node 30, your linked list should become 2010 or your stack becomes 2010. How it is executing? Let me explain. Pop S, S is your P here. So it is S or it is P. Then Q is P. Q, a new pointer is also pointing to first node. This is the node to be removed. So node to be removed is Q. You wanted to remove this Q. The next node becomes your first node of the stack. So P is Q next. Now this becomes P. P or you may say yes. P or yes. Then Q data is assigned to X. 30 is X. And Q will be freed and return X. X will be returned. So that the stack becomes a linked list consisting of only 2 nodes. Null. It contains 10, 20 and this is S or it is P. Outside the function it is S, inside the function it is P. Either S or P, which is nothing but it is stack or stack top. Stack top is 20, next node is 10, next node is null. Now again you wanted to pop one more node. X is equal to pop of S. Pop S. Pop S means pop stack. Pop stack means delete one node from the stack. So here again Q is P. First node you are going to remove. If you remove this node, the remaining next node becomes your top of the stack. So Q is P. P is Q next. This becomes P. This becomes P or this becomes S. Then Q data is 20. 20 will be assigned to X and Q will be freed. Free Q will be executed. Free Q means delete first node or delete top node. Then return X. X value will be returned. 20 will be returned and the stack becomes a linked list consisting of only one node now. Null 10 and this is top of the stack or you may say S or P. Now you have only one node. You have only one node. Stack contains only one node S 10 null. Again you wanted to pop X is equal to pop of S. I'm going to execute one more pop, that is remove next node also, one more node. There is only one node. If that is deleted, stack becomes null. See what happens. I'm calling pop S. S is nothing but your P. So S is P. You may call it as stack or you may call it as P. Then a variable Q is assigned to P. Q is also assigned to P. Then Q is going to be removed. Q is the node to be removed. Q is going to be removed. Q data is assigned to 10 and P is assigned to Q next. What is Q next? Null. This is P. P becomes null. PR, yes. Stack becomes null. Then free Q. Q is removed. So what is S? Null. Or what is P? P is null. So stack became null. See here, initially it started with 4 nodes. It started with 4 nodes. If you apply pop, it became 3 nodes. If you apply pop, it became 2 nodes. If you apply pop, it became 1 node. If you apply pop, it became null. Every time what you are removing, the most recently placed element or the first node of the linked list. See here, 40, 30, 20, 10, 40 is removed. In the second case, 30, 20, 10, 30 is removed. In third case, 20, 10, 20 is removed. In fourth case, there is only one node that is removed. Right? So, the most recently placed element is going to be removed, which is said to be pop operation. And I wanted to explain you about the function to display the nodes of a stack or linked list. Assume that there is a linked list consisting of 4 nodes, node 1, node 2, node 3, node 4. Next of node 4 is null, means a stack consisting of 3 nodes. It is a linked list. It is a linked list. Or you may say a pointer is pointing to first node. If you push one more node, a new node is added at front. If you delete, if you pop, first node will be deleted. So it is treated as a stack. Adding always at front, deleting always from front, which is nothing but the operation of stack, last in first out list. So we are using a stack, or we are implementing a stack with the help of a linked list, that is last in first out list. Now if I wanted to display the values of stack, that is here in this particular example, stack contains 4 nodes. First node information is 40, second node information is 30, third node information is 20, fourth node information is 10. See here, I'm going to display and all the values. Say display, yes, display, yes. What is yes? S is my stack. See here, I'm calling display function void p. So p is nothing but stack. So here p pointing to yes. P is a pointer pointing to S. So whenever I call display function, I am passing actual parameter, and in the function, the value, the actual parameter is copied into formal parameter. Formal parameter is P, S is actual parameter. So it may be called as S or P. S outside the function, P inside the display function. Now what happens in display function? See, while P is not null, is P pointing to first node, is it null? No, it is not null. So it enters into the loop. It is a while statement, means it is a repetitive statement. It is a loop statement. If P is not null, yes, P is pointing to some node, it is not null. So it enters into the loop. Printf P data. P data means 40. Then it prints an arrow. P is P next. P moves to next node. P is P next. This is next node. P pointing to next node. Now, again, because it is a loop, it checks, is P not null? Yes, P pointing to another node, not null. So it is not null. So again, these two statements are getting executed. P data is printed. P data is 30. 30 is printed, and one more arrow is printed. Then P is P next. P moves to next node. Again, while statement. While is a repetitive statement. Now every time it executes all the instructions of that particular loop body, the condition is compared. Is P not null? Yes, P is not null. P is 20. It is not null. So again, P data is printed. 20 is printed. Then arrow is printed. P is P next. P moves to next node. P is now pointing to 10. Is it null? No. So data is printed, arrow is printed, P is moved to next node. Again P condition, while condition. Is P not null? It is null. Now P is pointing to null. So terminate while statement. Terminate while statement. Next statement is executed. Printf null. Null is printed. End of the function. So 40, 30, 20, 10 is printed. So which is nothing but value of first node, value of second node, value of third node, value of fourth node. Then the next of fourth node is null, indicating that it is the last node of the linked list. Here it is a function to display information of nodes of all the nodes of a linked list, or displaying the nodes of a stack, because here we are implementing a stack using a linked list. So which is nothing but displaying nodes of a linked list.